Now, the first thing I want to ask y'all is, how many degrees are in a circle?
330.
360, right?
45.
Why 360? Why that number? Why did we choose 360? Does anybody know why we picked such a jacked up number for the number of degrees in the circle? Usually when we don't know the answer to these questions, it goes way back in history, right?
1947.
No, back further.
1444.
Keep going. Keep going.
16.
Like, this is the number 360 is straight from biblical times, y'all.
16 BC.
Keep going. Keep
I
going.
don't even know the years after that.
We're talking like 2,000 years before the birth of Christ. We're talking 2000 BC. We're talking about some dudes called the Babylonians. Okay? Why do we have 24 hours in a day? Babylonians. Why do we have 12 months in the year?
The Babylonians.
No, the Romans, but good guess. Why do we have 360 degrees in a circle? The Babylonians. Now, why were the Babylonians so obsessed with 360? They were their number system. How many digits are in our number system? How many digits? Not how many numbers. How many digits? I got 0. 0 is a digit, right? 1 is a digit. 2 is a digit. 3 is a digit. 4 is a digit. How many digits do I have in my number system? 10.
0.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
4, 5, 10, 0.
No, 9 plus 0.
Oh, no.
10 is not a digit. 10 is 1 and 0.
Okay.
Right? So, we are on a 10-digit number system. Girls, back there, please. The Babylonians were on a 60-digit number system.
They were advanced.
They were advanced in their way. But let me ask you this. Why do we have a 10-digit number system?
First,
Why does that work, Nick?
simple.
What am I doing right now?
Because you got 10 fingers.
I got 10 fingers. I'm counting with my fingers, right?
How many fingers are on the giraffe?
How many fingers does a Babylonian have?
10.
So how do they count using base 60 numbers?
What's the cool thing they used to do?
Yeah, that thing. Okay. 1,
Yeah.
2, 3,
Yes.
4, 5, 6,
9.
7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
Okay, so you don't count this one.
Now, 12 more is
69.
Brandon.
Alright.
12 more on that is 48, and 12 more on that is 60.
Yeah.
Do we see how the Babylonians counted now?
Yeah.
Sydney, why is your hand orange? Good reason. All right, so 360 degrees is a remnant to Babylonians and how they counted. All right, another thing. So who's got their calculator? Can I borrow your calculator for a second there? Thank you, Julia. So when you go on your computer, actually, I take that back. I'm going to give that back to you. I think I got it right here. When I turn this on, right, I'm going to clear, and I'm going to hit the mode button. Oh, they only got radians and degrees here. So, how many people got their calculators? They see rad, deg, deg. So you got 3 modes. You got degrees, which is like that on your calculator, right? You got radians, which is like that. And who sees this on their calculator? Who sees that on their calculator? That's something that they call gradients. And basically, it's the metric system of degrees. So instead of each quadrant, how many degrees is each quadrant? 90 degrees, right? There's 90 degrees in each quadrant. The idea here was, instead of making each quadrant 90 degrees, let's make each quadrant 100 degrees.
You should get the calculator.
And then, how many degrees would be in a circle? 400. So, nobody uses this anymore. Nobody uses this anymore. Today we're going to learn about radians, though. And radians is a beautiful thing, though you will not believe it at the outset. You will not believe that radians are a beautiful thing. All right? Now, what is a radian? I'm going to skip. Mr. Erickson's going to do page 2 with y'all. I'm not. We're going to skip page 1 and page 2. We're going to go straight to page 3. Yes. Where did I put them? Does anybody else not have a handout? Thank you. Now, let me ask you this. If I got a circle, I'm gonna actually, let's use that second page. Let's use that second page as some overflow room. So go to the bottom of the second page, and I want you to draw a circle. Draw a circle. Don't hate on my circle. It's just a circle. It's just a circle smushed a little bit. Go ahead. Okay. You want that for the rest of the day? You want to sit down here where there's a chair? Be my guest. You get the nice chair, Andrew.
Right here is where you're at.
Yeah, sit in the nice chair. Don't move this over. All right. So everybody got this circle here. Now, let me ask you this. If I got a line right there, and I got a line right there, and let's say this radius is what units do you want to use, Caleb? Inches. 2 inches. Okay, so that's 2 inches. Yes, sir. You're already late, Joe. You're already late. So, let me ask you this. If this angle, let's keep it easy. Let's say this is 60 degrees. If that angle is 60 degrees, how long is this arc right here? How long is that arc? Again, if 2 is my radius, how long is the arc? Remembers how to figure this out. This is like last year stuff, isn't it? You guys do arc lengths in geometry? You didn't do arc lengths in geometry? Really? Wow. Okay, let me ask you this. Be fortunate that I kept my angle a simple number. So, let me ask you this. How far is it around the whole circle? No, not degrees, distance. If I was an ant and I just walked this circle, how long would I walk? Not degrees, distance. Sure you do. You got the tools for that. I know you learned this in geometry.
10 inches.
How do you figure 10 inches?
Best guess.
Best guess.
8
What do you think,
inches.
Dominic? Zach? 4 pi. How do you get 4 pi? 2 pi r, right? So the whole circle is 2 pi times the radius. That's the circumference of the circle. Now, how far around of the circle did he walk? Did he walk around the whole circle? Did my ant walk around the whole circle? How much of the circle did he walk around? He walked 60 degrees out of how many degrees? 360, right? Can I simplify that fraction? It's 1/6, right? So if he walked 1/6 of the way around a circle, how far did he walk? 4 pi over 6? 2 pi over 3? Right? So, here's my point, is we can represent an angle by this arc length. And furthermore, let me ask you this. If he walked around the same circle, except that circle wasn't 2 inches in radius, it was 5 feet in radius. How far did he walk? If I just changed the 2 inches to 5 feet, how far did he walk?
4 pi. Or no, pi r.
2 pi r is the circumference, right? So if my radius is 5 feet, 2 times that is 10.
10 pi.
10 pi,
Square.
no, it's circumference. We don't square circumference. You're thinking area. You're thinking area. So 2 pi times 5 gets me 10 pi, right? You kept throwing a squared in there. Okay. And then what do? I times it by the 1/6, right? Because 60 degrees is still 1/6 of a circle. Okay? Now, let's forget about the 5 feet or the 2 inches. Okay? Because 60 degrees is still 1/6 of a circle, right? Now, if I do a unit circle, what's the definition of my unit circle? What is the definition of my unit circle? What's the radius of my unit circle? Why is it 1, Zach? Makes my math easier, right? So, if I'm in a unit circle, how far do I walk all the way around the circle? If I'm in a unit circle, which means my radius is 1, right? My radius is 1. How far do I go around an entire circle if my radius is 1? 2 pi, right? 2 pi. 2 pi is 1 whole revolution in radians. Okay? So to go 360 degrees, I go 2 pi radians. Are we clear on that? So, back to page 3. 360 degrees equals 2 pi radians. Okay? Now, the big thing you're going to have to do today, tomorrow, bless you, and bless you. Big thing you're going to have to do today, tomorrow, and going forward is knowing how to change degrees into radians and how to change radians into degrees. Okay? 360 degrees equals what?
Full turn.
How many radians? 2 pi, right? So, how many radians is 1 degree? How would I get 1 degree out of this? I could see,
360 radians. Wait,
if I divide both sides,
radian equals how many degrees?
what's that? Who cares about 1 radian? 360 degrees equals 2 pi radians, right? So if I divide this by 360, I'll get one degree here, right? And if I divide this side by 360, I should divide this side by 360, right? So now, 360 divided by 360 is 1. So 1 degree equals, can I simplify this fraction? What is it, Brooke? Yeah. Pi over 180. So if I got a degree measure, and I want to convert it to radians, what do I multiply it by? If I got degrees, let's say I got 30 degrees, and I want to convert it to radians. How would I do it? One degree equals pi over 180, right? So how many does 20 of them or 30 of them equal? So 30 degrees equals 30 times this, right? So 30 times pi over 180. Well, first thing I know is this has got a 10 in its factor, and I can cancel out with the 10 in that factor. So now I got 3 pi over 18. Can I reduce that fraction further? I get, what is that, 1 pi over 6, right? Pi over 6. So 30 degrees equals pi over 6 radians, right? How many degrees how many radians does 90 degrees equal? Go ahead and do that on your sheet. Cross out 5. And I want you to find 90 degrees equals what? How many radians is 90 degrees? It equals 90 times what? Pi times pi over 180. Good, Nick. And then I just simplify the fraction, right? So 90 goes into 180. How many times? Twice. So that's 1, that's a 2, and then it equals pi over 2 radians. Okay? Now, if I got radians and I want to go to degrees, how would I do that? Of course you do. We know that pi over 6 is 30 degrees, right?
Yeah.
What did I do to get pi over 6? I took 30 degrees and times it by pi over 180, right? How do I undo times pi over 180? So if I got pi over 6 radians, what do I multiply it by to get me back 30 degrees?
You have to find whatever that makes 6 equal.
Well, remember, I times by pi over 180. How do I undo times pi over 180? What's the opposite of timesing?
Divide.
Dividing. Dividing by pi over 180, right? Dividing is like multiplying by the reciprocal, right?
Change. Flip. Yeah.
So, can I do 180 over pi?
Sure.
What's that going to give me? What is the answer?
30.
These cancel out, right? I get 180 over 6. 6 goes into 18 3 times. Add the 10 at the end. Equals 30 degrees. Okay? Now, who's freaking out right now because they don't know whether to multiply by pi over 180 or divide by pi over 180? Okay? Now, here's what I like to do to cut through all that crap. Okay? Really? So, if I got a degree measure, if I have a degree measure, let's pick a degree measure. 45 degrees. And I want to make it a radian measure, right? Well, 45 is a fraction of a whole circle, right? Am I right? It's part of a whole circle, right? And that fraction of the whole circle is the same fraction whether it's in degrees or in radians. Am I right? And what's a whole circle in radians? 2 pi. Now, if I solve for x, I got the number of radians in that degree measure. What do we call this? We work these all the way back to maybe 5th or 6th grade. What's that, Jesse? It's an equation, but what kind of an equation? I think I heard it. Ratio. That's a ratio, ladies and gentlemen. How do I solve a ratio? How do I solve the ratio? How do I find x? Close. Close, Nick. Cross multiply. Cross multiply. So if I cross multiply, I get, let's do that in blue, 360x equals 45 times 2 pi. That's 90 pi. And then, how do I solve for x? Divide by 360. These go away. X equals 90 pi over 360. Can I simplify that? Yeah, Jesse's got it. Pi over 4. Pi over 4. Now, riddle me this, Batman. Did I do one more step than I needed to? What's this say? The right-hand side of this equation in red. What does it say? It says x divided by 2 pi, right? How do I undo divided by 2 pi? Multiply by 2 pi. Can't I just do this? And do the same thing? What happens to the 2 pi's over here? They cancel. Whack. What happens here? 2 pi times 45, that's 90 pi, right? Over 360? Over 360? Sounds like the same thing I had over here, doesn't it? Okay? Now, I'm going to back up a couple steps. All right. Now, let's say this is to convert degrees into radians, right? Now, to convert radians into degrees, this is going to be, that's going to be your x, and this is going to be your radian measure. Let's say, let's do blue. 3 pi over 4. So let's work this ratio to figure out what my degree measure is for 3 pi over 4 radians. Okay? Do the math. So now I got, if you cross multiply, what do you got? Go ahead, Michaela. 360 times 3 pi over 4 times 3 pi over 4 equals what? 2 pi x. Okay, very good. Let's simplify this guy first. 4 goes into 360 how many times? 90 times? 90 times 3 is 270 pi equals 2 pi x. I just simplified this fraction. 360 times 3 over 4 is 270. Now, how do I get x by itself?
Divided by 270. Or by pi, sorry.
2 pi, right? Divide by both sides, what happens to the pi's? They go away, right, Jeff? And then I got 270 divided by 2. 2 goes into 2 once.
135.
135, right. 135 degrees equals x. Do you see how the ratio prevents us from having to memorize stuff? Use the ratio. Use the ratio. The ratio is wonderful. Okay? So, tomorrow, we are going to go into this page right here. We're going to go into page 4, and we're going to get some more practice converting back and forth between degrees and radians. And then we are also going to do exercises 6 and 7 together. Exercises 6 and 7 are part of your homework that's due on Friday. Catch me on that? All right. We're doing 6 and 7 in class. I'm assigning more stuff for you. It'll be on Google Classroom. All right?